Assalamualaikum warahmatullahi wabarakatuh. So for the group project, me and my partner, I'm ATHIRAH NABILAH binti NAZRI, and my partner is ALLYA MAISARAH binti Muhammad NAZRI. So for the group project, we chosen a data from the Department of Environment on the river basins pollution monitoring. So for the introduction, river basins are vital sources of water for domestic, agricultural and industrial use, have led to the deterioration of water quality in several Malaysia basins. The river are classified as clean, slightly polluted or polluted based on the key water quality parameters. The study examined the river basin pollution monitoring dataset from data.gov.my, focusing on biochemical oxygen demand or BOD5 as a key indicator to classify basins as polluted from 2000 to 2021. The least square method is chosen in this study because it provides a systematic and objective way to determine the mathematical function that best fit the observed data by minimizing the sum of the square error between the observed value and the predicted values. So this is the data that we get from the Department of Environment. So the X refers to the number of basins, while Y refers to the proportion of basins.
Next, move to the linear function. The general function of linear is fx equal to a0 plus a1 x. From the data, we need to find x squared and x multiply y. Next, this is how we calculate to find the linear equation by using the least square method. First thing first, we need to apply that we calculate on previous slide on the formula. Then we apply the Cramer's rule until we get a0 and a1. A0 we get 0.73270099 and A1 we get the 0.70393239. And lastly, we apply A0 and A1 into the general function and we get the final answer is fx equal to 0.7233 plus 0.7039x. This is the graph of linear function based on the final answer from previous slide. Next, we move to the sum of square error of linear function. Based on the table shown, each row represents one data point including the actual value, the value predicted by the linear function, the error and the square error. The error is obtained by subtracting the predicted value from the actual value. Each error is then squared to ensure all values are positive. The sum of square error is calculated by adding all the square error values listed in the last column of the table. From the table, the total sum of square error SSE for the linear function is 22.3005. This relatively low SSE value indicates that the linear model provides a good fit to the data, as the predicted value are close to the actual value for most observations.
Next, we move to the quadratic function. So the general function of the quadratic is fx equal to a plus ax squared. So from the data that we chosen previously on the data.gov from the Department of Environment, we need to find the x squared, x to the power of 3, x to the power of 4, and x times y, and x squared to the, times y. For this slide, I will explain how we obtain the final quadratic equation using the least square method. So first thing first, we need to assume that the relationship between the variables can be modeled by a quadratic function, which is fx equal to a0 plus a1x plus a2x squared. Then we need to apply the least square method to determine the quadratic equation. And then we we need to find the coefficient for the A0, A1, and A2. Thus, we got the final answer for the quadratic equation, which is fx equal to 1.52662 plus 0.66258x plus 0.0003230 squared. So this is the graph of quadratic function based on the quadratic equation that we got. So for this slide, I will explain the sum of square error or SSE for the quadratic model. Using the quadratic equation that we obtained earlier, which is fs equal to 1.52662 plus 0.66258x plus 0.0003230 squared. We calculated the predicted or calculated values for each x. Next, we need to find the error by subtracting the actual value from the calculated value. Since some errors are positive and some are negative, we need to square each error to make all values positive and to emphasize larger deviations. These values are shown in the error square column. Then we need to add all of the square error together to obtain the sum of square error.
In conclusion, the least square regression analysis of Malaysia River Basin BOD5 pollution data yields a sum of square error SSE of 22.3005 for the fitted trend line, indicating a strong model fit that captured the observed decline from a peak of 89% polluted basin in 2014 to just 6% by 2021 across 120 to 144 monitor basin. This low SSE value compared to the alternative model higher 25.0246 confirm the selected linear trends, superior accuracy in minimizing residual and reliable modeling long-term water quality improvement driven by DOE intervention. His finding underscore effective pollution control measure supporting sustainable river restoration while highlighting the model utility for future environmental forecasting. Based on our finding, the model with the smallest sum of square error to 22.3005 is the best fit because it has a lower overall prediction of error compared to the model with sum of square error 25.0246. Thank you for watching.